Now here with example 2, what we're kind of doing is really leading up into our next section, which are lesson 37 and 38, I believe. And this is just kind of, the whole goal is to create brand new identities. Is we know that if I take sine squared and cosine squared, we get 1. If I take cotangent squared plus 1, I get cosecant squared. So these are kind of some things that we know. And what this problem is kind of leading us up, it's kind of baby steps here. We have secant to the 4th x minus 3 secant squared x. And what I want to do is take away these secants, and I want to leave it to where all I have left are tangent squareds, or either tangent squares, just any kind of power, but I just want tangents in there. I don't want secants, I don't want cosines or sines, I just want to leave tangents behind. And a lot of times when I start with these, what I want to do is, sometimes off to the side, I kind of come over and I just write myself out my quick identities. Okay, so I know that cosine squared, I guess, whatever you want your angle to be, do you want them t's, x's, thetas? But I'll just do sine squared theta equals 1. I know that cotangent squared theta plus 1 is equal to cosecant squared theta. And I know that tangent squared theta plus 1 is equal to secant squared theta. So with this first one here in A, I want to figure out what can I replace all my secants with to where maybe what stays behind hopefully is a tangent, because I just want it all in just terms of tangent. If I go to this third one right here, it says that I can replace my secants, the secant squareds, with tangent squared plus 1. Okay. Well, this, I don't have a secant squared in this first one, I have a secant to the 4th. But I can write it as secant squared x times secant squared x minus 3 secant squared x. So all three of these, technically secant squared x, is I can replace them with tangent squared x plus 1. So I have tangent squared x plus 1 times tangent squared x plus 1 minus 3 times tangent squared x plus 1. Okay? And then from there, technically this is all in terms of tangents. So technically we're done with the answer, but of course, if there's any algebra left over, we want to clean it up. So let's FOIL out these first two parentheses. Tangent to the 4th x plus tangent squared and tangent squared are 2 tangent squared x's, and 1 times 1 is 1. And let's distribute the 3 here, so minus 3 tangent squared x plus 3. All we have to do is combine some like terms. I only have 1 tangent to the 4th x. I've got 2 tangent squared minus 3 tangent squared, so a negative tangent squared x, and 1 and 3 is 4. Okay? And so this right here is what they're looking for. I rewrote secant to the 4th x minus 3 secant squared x, all in terms of just tangents. Again, you're going to do a substitution, and if there's any algebra left that you can help kind of clean up, that's what you're going to go for. So let's look here at the part B. We want to express this new this fraction in terms of just cosines. So I've got a cosine there, that one's done, but I want to replace the sines right here. And of course we definitely know a formula that will tell us if we want to remove sine squareds and leave in cosines or cosine squareds, we're just going to go to the very, very first one. So we're going to use that whole fact of that sine squared t is equal to 1 minus cosine squared t. Okay, so we're going to bank on that one right there. Let's come down now. Everywhere I see a sine squared, I'm going to do 1 minus cosine squared. So 6 times sine squared, so 6 times 1 minus cosine squared t plus cosine t minus 5 over 4 times sine squared, so 4 times 1 minus cosine squared t minus 3. Okay, let's clean up the top. So 6 minus 6 cosine squared t plus cosine t minus 5 over 4 minus 4 cosine squared t minus 3. Okay, so keeping on. We have a negative 6 cosine squared t plus cosine t, 6 minus 5 is a positive 1, over a negative 4 cosine squared t, and 4 minus 3 is a positive 1. Alright, so from here, what I've done so far is I've replaced all my sine squareds with terms involve cosine, and I'm just kind of cleaning it up, because from here on out we're just doing algebra. And anytime I want to see if I can reduce a fraction, remember, you have to factor first. I can't just cancel off these cosine squareds. The only way you can cancel in a fraction is if you see the factors. So that's what we're going to want to do, is we want to factor this. Okay. So to factor this, let's set up 2 parentheses. It looks like here in the top, what's being squared is cosine squared, so with a 6, so we have 3 and 2 with a cosine t times a cosine t being our cosine squared, and here in the back we've got 1s. And the only factors of 1s are either both positive or both negative. I'm going to start out with both positive and see what we can get. And what I need is, since I need negative 6 to be in the front, I need either 3 to be positive or 3 to be negative. And it looks like, because we want to add up to a positive 1 cosine, we want that one to be negative. So outside would give us a 3 cosine t minus 2 cosine t, which gives 1, and then from there. Okay, so here in the bottom, we are going to have, let's see, again, looks like a 2 cosine t and a 2 cosine t, one of these being positive, one being negative, and the only factors of 1 are 1 and 1, so let's check. Outside is a 2 cosine t, inside's negative 2, which wipes away the middle, which is great, and then positive 1. Okay, so we have 2 common terms right here that we can cancel those off. So our answer is 3 cosine t plus 1 over 2 cosine t plus 1. And there we go. That is what the very first fraction is actually equivalent to by the time we take it in terms of sine and cosine into strictly just cosines. All right.